Okay, so we already talked about what angles of elevation and depression are, and here's a picture of what they are. I'm going to continue on. In this diagram at the right, angle 1 here is an angle, right here, is an angle of elevation from the tower to the plane. Okay, and angle 2 is an angle of depression from the plane looking down to the tower. So you got to think about where you're looking from. We're going to classify the following angles as angles of elevation or direction. First of all, I'm going to highlight the horizontal lines. The horizontal lines are all kind of like imaginary lines. Those are your lines of sight from the eyeball, or all the horizontal lines. So if you're coming from the tree, you might be looking up or down. If you're coming from, maybe there's a squirrel down here by the bottom of the tree. So if I was looking at angle 1 from the horizon line, that is opening down. And so that would be an angle of depression. Let's use DEP for depression. I'm going to put a T by the tree at the top of the tree. And then I'm going to put let's just say that looks like it is a man. So let's put a man there. And we'll put the bottom of the tree over here at the bottom of the tree. And now we can describe them. So this angle 1 is an angle of depression from the tree to, oopsie, that was a cruddy line I just drew. From the tree to the man. Okay, so it's opening down from the tree to the man. You're looking from the top, so there must be a bird up in the top of the tree. Tree to man, T to M. Angle 2 is that opening up or down from that blue horizontal line. Well, that angle is opening upward, and it would be from the man's face looking at the top of the tree. So this would be an angle of elevation. You can write ELEV for right now, and that would be man to tree, or M to T. Angle 3, now we're going from the man's face, that's the horizon line, from that blue line, and it's opening towards the bottom of the tree. So this is an angle of depression from the M, the man, to the bottom of the tree, M to B. And finally, where the pointy vertex of the angle is at B now, and now that squirrel at the bottom of the tree is looking up at the man. So that would be an angle of elevation, bottom of the tree to the man, B to M. Okay, so that's a description. Now we're going to do a few examples of using them in applications. There's a lot of places where this is used. The angle of elevation from point A to the top of a cliff is 34 degrees. So we need a point A. We also need a cliff. So the angle of elevation from point A to the top of the cliff is 34 degrees. So if I'm going to put 34 degrees here by angle A, I'm missing part of my angle. What do I need to draw? The ground. Okay. I made my cliff be a little tall. There we go. Chop that off. All right, so this would be the ground. So I've got the ground, and angle of elevation is my horizontal line. That's your ground. Your horizontal line is your ground. And it says that if point A is 1,000 feet from the base of the cliff, how high is the cliff? All right, so that's what next you need to determine where to put those numbers and where do you need to put an X. So it says point A is 1,000 feet from the base of the cliff. Well, I put it on a leg of the triangle or on the hypotenuse. This would be in the air. So is that where's the base of the cliff, guys? That's where the right angle is. Yep. That would be the base of the cliff. The base of anything is at its bottom, okay? The bottom on the ground. So it says a point A is 1,000 feet from the base of the cliff. Our 1,000 must go here. And then it says how high is the cliff. That's going to be X right there on how high it is. We don't need that hypotenuse. All right, so we're going to set this up now by realizing that opposite our 34 is our X, and adjacent to it is a leg, that's 1,000. Opposite and adjacent tells me, and I think about my mnemonic, Oscar has a heap of apples. That goes sine, cosine, tangent on your calc. Tangent of an angle, cosine of an angle. Okay, so this one's going to be tangent because I'm working with opposite and adjacent. So that's the tangent of 34 degrees equals the opposite leg x to the adjacent 1,000. Okay, you guys have been getting really good at setting these up. So it's really not much new here, except that we have to still be doing some application work problems. Cross multiply, we get x equals 1,000 times the tangent of 34. Oops. Now, I'm sure a lot of you already typed in 1,000 tan 34. What did you get? 674.5? Okay. Does anybody have a question about what to type in the calculator? Just type this. That's not what you got? All right, let's find out. So we might need to check something on your calculator if you don't get this. So I'm glad to see everybody is typing these. It was 34, right? All right, so I got 674.5. So what it means, Chloe, you might be in the wrong mode. Somebody might have been messing around with the calculator. So if you press the mode button, it needs to be on degrees. Is it on radian? Okay. So everybody check that if you didn't get that answer. That's why it's so important for you to be working along with me. Not only that, there is a physical memory to your body sometimes of what things that you did, even though that's the smallest thing is typing on a calculator. Practicing when we're doing these problems and actually doing these calculations instead of waiting for others to do them, it will make you remember what to do later. Okay, it helps a lot with your memory. All right, next example. Angle of depression from the man on top of a hill. All right, so I got to make a man. I'll make a little stick figure. I don't know why it's guy, but anyway, he's on top of a hill. All right, so I'll make him on top of a hill. Okay, it says the angle of depression from a man on top of a hill. Now, if there's a man looking, you have to draw in his line of sight. That's that imaginary line that comes out from his eyeballs. Unless he has x-ray vision or something. I don't know. Anyway, so now it says that the angle of depression from a man, so there's an angle of depression. So he's looking down at something at a target. Well, I drew this huge. Let's make our ground down here and get that hill to not be so tall. All right. So let's see. He's looking down at a target. So let's just say, unfortunately, there is a moose or something down here. I don't know. Aw, poor guy. So anyway, he's got a target. I could have made it a bullseye. That would have been nicer of me. But this is your angle of depression. So that's opening down from that horizon line, and it said it was 19 degrees. Now it says if the target is 80 feet from the base of the hill, where would that go? All right, so again, where's your base? Right here. All right, so if I'm 80 feet from there, all right. Oh, that's not even looking like an 80. I made a mess. Okay, so I'll write it better, 80 feet. And I'm just feeling a little bit guilty that there's an animal there, so I think I'll just make it a bullseye. I'll make it a target. There we go. Now it's just a rock or something, or a bullseye. Right, he's shooting arrows. How far does the arrow have to travel to hit the target? Where's that arrow going to fly through? When you shoot an arrow, what's it fly through? It's flying through the what? The air. Okay, this is your air right in here. All right, so it's going to go down at the target like that. It's sort of like its line of bam. It's going to hit it. Hopefully, if he's a good shot. All right. How am I going to solve this problem? What's it asking me? It says, how far does it have to travel? X. All right. What's a deal with this problem? I got this big triangle right here, but well, it is cosine, but how? Okay, so I just need you guys to realize that when you have an angle of depression, it's equal to its corresponding angle of elevation. So this is actually an angle of elevation. These are equal because of our alternate interior angles, okay? So you can put the 19 down here too. And now it would be cosine because this would be your adjacent leg and this would be your hypotenuse. So the cosine of 19 equals 80 over x. Okay, now we're going to think about our cross product properties. So we got x times the cosine of 19 equals 80. And then you're going to divide 80 by the cosine of 19. So how far has he got to shoot his arrow? Make sure you're typing that right. And this is what I'm talking about, physical memory, remembering what to do as far as how you have to calculate this. 19, 84.6. And that's going to be in feet. Okay, need labels. All right, let's go to the packet, the practice that we're going to do today about angles of elevation and depression. After this lesson, you should be able to successfully solve problems using angles of elevation and depression. All right, we've already started on it. This is just some more examples of an angle of elevation, both of these, looking from there to the top of the tree, and angles of depression, looking downward. All right, let's just go for it. On our packet, we have a problem right away to begin with. I'm going to put an X where the question mark is. And I think that unfortunately, like, you don't even really have to read this if you look over the triangle, but it says the angle of elevation from point A to the top of a hill. So this is your hill, and that would be your angle of elevation coming off the horizontal line of 400 feet. 400 feet from the base of the hill, how high is the hill? So opposite over adjacent, this would be your tangent because across from the 49 is the opposite leg and adjacent leg is the 400. ADJ. So I messed that up. Tangent of 49 is x over 400. We've been calculating these over and over. So x is going to be 400 times the tangent of 49. 400 tan 49 on your calc should be giving you 460.1 feet. Okay. Number 2, you want to know the angle of elevation of the sun in this one. It's telling you that there's a telephone pole that's 12.5 meters casting a shadow that's 18 meters on, and shadows are always on the ground. Okay, so this is the angle we want to find. Opposite and adjacent, this is going to be tangent, but this time it's a tangent of x. The angle we're finding, x degrees, equals 12.5 over 18. Now, what do we do when we find an angle? Second buttons, right? Okay, thanks to Kasha. So you hit second tangent, and it'll be a little -1 on it. Second tan of 12.5 divided by 18. And it'll get you the angle you need. All right, 34.8 degrees. If you're rounding to the nearest tenth of a degree, you're going to go after this first 7 and see that 7, round that 7 up to 34.8, excuse me. So then 34.8, you need degrees on your answer because it's in degrees. Number 3, oh, here's another application. Do you think skiers want to know what the angle of a slope is? Probably. Why do you think that there's black diamond slope ski runs and bunny hills? What's the difference? How steep the slope is. So would the angle be larger or smaller if it's getting steeper? Be a larger angle. Okay, your angle of depression is the angle at which you're going to go down the slope. So it says this, a ski run that's 1,000 yards long, that's the hypotenuse, with a vertical drop of 108. I don't know what that is yet. Find the angle of depression from the top of the ski run to the bottom. Well, if this is what we want to find, it's equivalent to this by alternate interior angles. Okay, so we're going to find this angle. So I don't know. I got to do something to x. Opposite would be your 208, and hypotenuse tells me to use the sine. So the sine of x degrees equals 208 over 1,000. So we're going to hit second sine. It will look like this on your calculator and put in that fraction. Second sine 208 divided by 1,000. We just had the Winter Olympics recently. Those guys can ski down a slope that I sure couldn't. 12 degrees. That's not all that steep. What do you think about 45 degrees, though? I think it's like too steep. That's really bad. Really, really steep. Half of 90. Oof. From the top of 100, now air traffic controllers, these pilots and stuff, they all need to know trigonometry, especially if their instruments fail them. I can put the 19 down here in this diagram. From the top of a 120-foot tower, an air traffic controller observes an airplane on the runway at an angle of depression of 19. How far from the base of the tower is the airplane? So we want to know this. That in relationship to this angle, we had to realize we can do our alternate interior angles are congruent. So that's your opposite. And then you want to, that's a weird looking P. You want to find the adjacent leg. So we got tangent. So the tangent of 19 is 120 over x. Careful on your calculations, because this is going to be x times the tangent of 19 equals 120 when you cross multiply. And then you're going to divide. Now, I know some of you realized a shortcut when you think about x being on the bottom, but if you don't really know that, then just do what I'm doing. I've always been cross multiplying, and then you can see you need to divide. 120 divided by the tangent of 19, 348.5. And that's in feet, so the answer is in feet, since the height of the tower was in feet. Okay, so far good? All right, so now I want us to name these properly, and I'm going to use 3 letters to name my angles. These are not numbered, so we need 3 letters to name an angle. The horizon line is FL, so I'm going to say angle FLS. Is that an angle of elevation or depression? It's opening down from a horizontal line. So that is an angle FLS is an angle of depression. You can use DEP, and it's going from, the angle is coming from the helicopter at L to point S, which is at the top of the building. So to describe it, angle FLS is an angle of depression from L to S. Now, when I name the next angle, I'm going to start with the horizontal line. So I'm going to say angle TS and then go to L. Angle TSL is an angle of, it's opening up from the horizon line, angle of elevation. And that's from the top of the building to the helicopter. So it's from S to L. Are you understanding what the last part is about? It's just saying where the angle is coming from and where you're looking to. All right, so number 6, angle RTW is looking down from the wheel. I'm going to even say wheel. Angle RTW, maybe because that might have been confusing on the last one if you didn't get it. Angle RTW is an angle, oopsie, of depression. Wheel to the man or figure or person. Okay. And the angle going up, SWT, is an angle of elevation. And now it's coming from the man looking up at the wheel. Man to wheel. Okay. Hope we're getting that. I just drew my arrow kind of weird. Excuse me. All right, try these. You can say, I'm going to call this a deer and a cabin. And of course, this is a balloon and a person, or it's easier to write man because it's fast. 3 letters. Okay, so can someone describe for me that top angle here? Come on, I need a volunteer. You guys usually perk up a little quicker than that. Name the angle and tell me what kind it is. Are you ahead of me? How many of you are ahead of me? Well, not that many. It's only like a third. Okay. I bet you're going to want me to help with Nabucco and the mountain thing. Number 9. All right. All right, so just really quick, then I'll just say what you should have for 7 and 8. It should be angle DCA is the angle of elevation, and it's going to be deer, or if you went C to B, deer to cabin, or you can say C to B. Angle ABC is an angle of I wrote elevation. Oh my gosh, I can't believe I did that because my brain was going somewhere else. That's not elevation, it's opening down, isn't it? Should be depression. The next one's an angle of elevation. Okay, going up from cabin to deer. Or if you wrote letters, it would be B to C. Cadence? Oh my gosh, how did I write I didn't even write the right letter. DCB, of course it would be. I have no idea what happened to me on that first question there. Something went in my head, I guess. I have no idea. All right, this is angle WZP. And it's an angle of depression, balloon to man. Or Z to P if you use letters. And the other one, angle RPZ, would be an angle of elevation. And that would have been man, or P to Z. Man to balloon. Okay, this is the one I thought we might want some help with. It's just, you look at it and go, wow, that's a long word problem. It's not that bad, though. Mountain biking. On a mountain bike trip along the Gemini Bridges Trail in Moab, Utah, Nabucco stopped on the canyon floor to get a good view of the twin sandstone bridges. All right, that's all extra information in a sense. Nabucco's standing about 60 meters from the base of the canyon cliff. So on the ground, she's standing 60 meters from the base of the canyon cliff. All right, I don't know. And the natural arch bridges are about 100 meters up the canyon wall. Okay, so let's just say they're up here somewhere. I don't know what they look like, but this distance is 100. Okay, so I'm going to say that whole distance from here to here is 100. And then she's looking up, and it says if her line of sight is 5 meters above the ground, and she's looking up at an angle, it doesn't say what's it. It says, what's the angle of elevation to the top of the bridges? So I'm going to be finding this angle. But it says she's got her eyeballs 5 feet off the ground, or meters. Oh my gosh, she's so tall. She's 15 feet tall. sorry, line of sight is 15 meters above the ground. All right, so this is 5, which means now that 100 isn't really my 100. What is it? What's this going to be now? Not 100. It's going to be 95 because you got to chop off 5. All right, so now I can figure out, oh, and this 60 can be transferred to there. That's fine. So I've got opposite and adjacent. So I'm going to be doing the tangent of x is 95 over 60. So we're finding an angle measure. So we're just going to hit our second tangent, 95 divided by 60. And that angle is going to be 57.7 degrees. Okay. And number 10, that one's pretty much straightforward here. Suppose the sun casts a shadow off a 35-foot building. If the angle of elevation of the sun is 60 degrees, that's because your sun would be up here somewhere shining some light, creating a shadow from the building. How long is the shadow to the nearest tenth of a foot? Shadows are always on the ground. Please do not put them in the air. You can't see them in the air. The air is see-through for the most part. Opposite adjacent, that's going to be another tangent. Tangent of 60 will be 35 over x. So we got x on the bottom. Be careful. X times the tangent of 60 will give you 35. You would divide by tan 60. Okay, so 35 divided by the tangent of 60. I've got 20.2. And that's in feet. All right, so and then indirect measurement. Kyle's at the end of a pier 30 feet above the ocean. His eye level's 3 feet above the pier. So that means we have a total right here of 33 feet. He is using binoculars to watch a whale surface. If the angle of depression of the whale is 20 degrees, how far is the whale from Kyle's binoculars? So his binoculars are up here by his eyes, so that's going to be this number, whatever that is, a hypotenuse. The angle of depression equals the angle of elevation from the whale to Kyle. If the whale is looking at Kyle, the angle's the same there. How far is the whale from Kyle's binoculars? Let's say we got opposite and hypotenuse. So that's going to be sine. So the sine of 20 equals 33 over x. Careful on your calculations. It's not just a multiply, because x times the sine of 20 equals 33. So x is going to be 33 divided by the sine of 20. At 96.5. And that's in feet. That's really close to be from a whale. Okay, you have some practice you can do right now. Got some little bit of time. Please be ready with questions tomorrow on this, as we will be answering questions and getting prepared for our quiz on Friday. We're going to have a right triangle trig quiz Friday with a few word problems, or in 2 days.